Alright, we are going to look at actually solving the logarithms. This is part one. So far we've just looked at switching from exponential to logarithmic, or logarithmic to exponential. Now we're going to look at actually solving for x, okay? So one way we can solve for x is if you have log base b, so log of some number of x equal to log base b of y, then x has to equal y. So if your logs and the bases are the same, then x has to equal y. Okay? Log and base are the same, then x equals y. So if I had log base 5 of 10 equal log base 5 of x, well, if my log base 5 is the same on both sides, then 10 equals x, or x equals 10. Do you see it? These are the same, so I can cover them up. 10 equals x. Okay? So let's look at an example. If I want to solve for x, if I have log of 3x plus 6 equal to log of 5x. First of all, I don't see a base, which means they both have a base of 10. Okay, so the bases are the same, which means 3x plus 6 equals 5x. They're separated by an equal sign, right? So essentially I'm just dropping the log and leaving that as my equation. 3x plus 6 equals 5x. And then now I'm going to solve this equation for x. So I would take away 3x's from both sides. I have 6 equals 5x minus 3x is 2x. Divide both sides by 2. And we get x equals 3. Okay, let's try it again. I have ln on both sides, which is log base e. So same on both sides. So that's my equation. 4x plus 6 equals x plus 12. And let's solve. So I'd take away an x from both sides. And I have 3x plus 6 equals 12. Minus 6 on both sides. And I get 3x equals 6. Divide both sides by 3. And we get x equals 2. Alright, and once again, log base e on both sides, so this would be my equation. So I have 8 minus 3x equals 8 minus 2x. So I want to get my x's on the same side. I would add the 3x to both sides because then that's going to make your x's positive. Because a negative 2x plus 3x's gives you a positive 1x. Brought down this 8, brought down this 8, that became a positive x. So now subtract 8 on both sides, and I end up with 0 equals x, which is perfectly fine. X can equal 0, and there's nothing wrong with that. Another way to solve logs is to rewrite them in exponential form and then solve. So if I had log base 3 of 81 equals x, and I wanted to find x, I could rewrite this in exponential form. So 3, my base 3 raised to the power of x equals 81. Well, 81 with a base of 3 is 3 to the 4th. Bases are the same, which means my exponents are equal. So we get x equals 4. Same thing can be applied here. I don't see a base here, which means it is a base of 10. So I have 10 raised to the second power equals 4x plus 8. 10 raised to the second power is 100. So 100 equals 4x plus 8. Minus 8 on both sides. And I get 92 equals 4x. Divide both sides by 4. And we get x equals 23. Okay. All right. Here, we have base 5 raised to the power of x equals 5 to the 4th power. Bases are the same, which means x equals 4. This is what we learned a couple days ago, right? Okay, let's do another one. 6 raised to the power of 0 equals x. Well, anything raised to the power of 0 is 1. So that would mean 1 equals x. Any number raised to the power of 0 is always 1. Okay, one more. It's ln, which means it's really log base e. So I'm saying e to the power of x equals e to the 3rd power. Same base, which means exponents are equal, so x equals 3. All right, we have 3 to the power of x equals 1/27th. Which means I need to rewrite 1/27th to have a base of 3. Okay, so I'm going to rewrite it as 3 to the negative, right, because that's going to move 27 up, -3. Which means bases are the same, so exponents are equal, x equals -3. Okay, this one is a little trickier. This one requires a little more work. Okay, so let's take a look at this one. All right, the reason I know this is going to be a little bit trickier is because I see an x squared, which means I have a quadratic. So let's take a look. I both have a natural log on both sides, ln on both sides, my natural log, which means they're log base e, they're the same, so that means 4x plus 12 equals x squared plus 5x. Okay, so I have x's and I have an x squared. Okay, so I'm going to get everything on the same side with my x squared because I have a quadratic, which means we want 0 to equal ax squared plus bx plus c. Okay, that's what we want to happen. So I'm going to do a minus 4x on both sides. So losing is 12 equals x squared plus x. Now I'm going to do minus 12 on both sides. So now I have 0 equals x squared plus x minus 12, which is what I wanted. The reason I want it like this is because if you remember back when we did solving quadratics, we can solve them by factoring them, okay? So I'm going to factor this trinomial. My a is 1, my b is 1, my c is -12, okay? I don't have a GCF, or my GCF is just 1. So I don't have to do anything when my GCF is 1. My a is 1, so that's going to be nice. So I'm going to go ahead and Xbox this, a times c, and my b. So 1 times -12 is -12, and my b is 1. So what would multiply to equal 12? Well, 1 times 12, 2 times 6, and 3 times 4. But they need to multiply to be a -12, so 1 would have to be negative. And then when you add them, they're going to be a positive 1, which means my bigger numbers are positive in order to keep it positive. So -3 plus 4 is 1. So that means my factors are going to be x minus 3 and x plus 4. Okay. Now what I can do to actually figure out what x is set each of these things equal to 0 individually. So I have 0 equals x minus 3, and I have 0 equals x plus 4. And solve. So I get x equals 3 as one of my answers. And then I get x equals -4 as my other answer.